You ever look up at the night sky, just packed with stars, and get this feeling of, well, both awe and a little bit of loneliness? The universe is so unbelievably huge, so ancient. Which brings us to one of the most profound and frankly haunting questions we've ever thought to ask. Where is everybody?
So let's get into it. This whole thing kicked off way back in 1950. The legendary physicist Enrico Fermi is just having lunch with some colleagues, talking about flying saucers and aliens. And after doing some quick mental math, he just blurts it out. Where is everybody? Such a simple question, right? But it completely changed the conversation, and it's been echoing through science ever since.
All right, to really get why that question is such a big deal, we have to play a little game, a cosmic numbers game. And believe me, when you see the scale we're talking about, it seems obvious that the universe should be absolutely buzzing with life.
Okay, let's start small, or, galaxy small. Right here in our own Milky Way, astronomers estimate there are at least 200 billion stars. And just to be clear, that's not 200 billion planets. That's 200 billion suns, each one a potential anchor for a whole system of planets.
Now, brace yourself, because this is where it gets totally mind-bending. Our galaxy, it's just one of an estimated 2 trillion galaxies out there. That number it's just staggering, almost impossible to wrap your head around. Every tiny speck of light in those deep space photos is an entire galaxy, each one with its own billions of stars.
And here's the thing, we know for a fact now that planets are not rare. They're everywhere. We call them exoplanets, and thanks to incredible telescopes, we've already confirmed thousands of them. And that's just scratching the surface. It turns out planets are a totally normal part of the universe.
But here it is. This is the number that really gets you. Scientists have crunched the data, and their best guess is that there could be up to 40 billion planets that are roughly Earth-sized and in the habitable zone of their star. And that's not in the whole universe. That's right here in our galaxy alone. 40 billion potential homes for life, just in our cosmic neighborhood.
So you put all that together, trillions of galaxies, billions of potentially habitable planets in each one, and billions of years for something to happen? The math just seems to scream one thing. The universe should be a bustling, noisy intergalactic metropolis.
But it isn't. And that's where things get weird. That's the core of the mystery. Because when we actually listen, when we look for all that life, we get nothing. Just silence.
For all the overwhelming odds that say life should be common, the reality on the ground is stark. We haven't found a single thing. No messages, no alien megastructures, not one piece of undeniable evidence that anyone else is out there. It's just a profound cosmic quiet. And that right there, that's the Fermi Paradox in a nutshell. It's this massive contradiction between the numbers, which say the universe should be full, and the evidence, which says it's empty.
And hey, it's not like we haven't been trying to find something. For decades, projects like SETI have been listening to the stars with radio telescopes. Now we have Breakthrough Listen, this massive $100 million project doing the most intense search ever. And the result after all that time, money, and effort? A big fat zero. Not a single confirmed signal.
So, what gives? Why the silence? I mean, this is the big question, right? And scientists have come up with a ton of possible answers, and they range from the pretty straightforward to the downright bone-chilling.
The theories are all over the place. Maybe we really are alone, a total fluke. Or maybe they're out there, but they're hiding from us, watching us, like we're some kind of exhibit in a cosmic zoo. A darker idea is that civilizations just don't last. They rise up and then they destroy themselves. Or maybe it's just that space is too ridiculously big to ever cross. And then there's this wild thought. What if we're not late to the party? What if we're the first ones to show up?
Let's just compare two of these big ideas. On one side, you've got the rare Earth hypothesis. This says that the recipe for intelligent life, a stable sun, a big moon, plate tectonics, all of it is so insanely specific that it basically never happens. We are, for all intents and purposes, a miracle. But on the other side, you've got the firstborn hypothesis. This idea says, hey, the universe is actually still pretty young. Maybe we're just one of the first civilizations to ever get this far.
But there is another idea, an explanation that's a lot more unsettling. And it has huge implications for our own future. It's a concept known as the Great Filter.
So the idea goes like this. On the long road from simple life to a civilization that can travel between the stars, there's a barrier, a filter. A challenge that is so incredibly hard to overcome that almost nobody gets past it.
It's the thing that stops life from taking over the galaxy.
Think of it like a cosmic obstacle course. First, you need life to even start. Then, it's got to get complex. Then, multicellular. Then, smart. Then it has to build a global civilization. And then, and this might be the biggest hurdle of all, it has to not wipe itself out with its own technology.
The whole theory of the Great Filter hangs on this one idea, that at least one of those steps is so monumentally, almost impossibly difficult, that it's the roadblock for basically everyone. And that would explain the silence. It's not that life is rare, it's that life that makes it is rare.
And this is where it all comes back to us, because this abstract, cosmic idea forces us to ask a really personal, really urgent question about ourselves. If this great filter is real, where are we in the story?
This really is the most important question for the future of our species. Is that filter, that nearly impossible, civilization-ending barrier, is it in our rearview mirror, or is it still waiting for us, up ahead?
And that leaves us with two completely different fates. Option 1, the filter is behind us. That's great news. It means that just getting to where we are now was the impossible step. We're special. We made it. But option 2 is that the filter is still ahead of us. This means some future test, nuclear war, climate collapse, some technology we can't even imagine yet, is the wall that almost nobody gets past. And in that scenario, we could be totally doomed.
Which leads to this crazy, chilling thought. You'd think finding the ruins of an ancient, dead alien civilization would be the most exciting discovery ever, right? But with the Great Filter in mind, it would be the absolute worst, most terrifying news humanity could possibly receive. Because it would mean that smart, technological civilizations can get to where we are, but they don't get much further. It would be a sign that the filter is still in front of us.
So maybe the silence isn't empty after all. Maybe it's sending a message, a warning. The absence of evidence becomes the evidence. The silence of the universe isn't just quiet, it's shouting at us.
And that leaves us right here, on our little blue dot, wondering, in this great, silent cosmos, is our noisy little civilization the start of something new and hopeful? Or are we just another brief, fleeting echo that's about to fade away?